Okay, in example 114, we're going to use theorem 1.1 to evaluate these limits. So theorem 1.1 says that if p is a polynomial function and c is any real number, then the limit as x approaches c of p of x is just p of c. You just plug in c in for x and that will be the limit. I think I've mentioned this in a previous video, but here's the actual theorem written down. And so x squared plus x plus 1 is a polynomial function. And so this tells us that if we want to know what the limit as x approaches 1, then that's the same as we're just plugging in 1. Sorry. So I just need to plug in 1 for x. And so you get a limit of 3. So you just, because it's a polynomial function, you can just plug in 1 and add up the 3 ones, you get the limit is 3 there. Now, the expression on the right is not a polynomial, it's a rational function, but we can simplify it as long as x does not equal 1. We can actually cancel out an x minus 1 from the top and bottom. So that's what we're going to do. So we write this as x minus 1 over x minus 1, and then I think I need x squared plus x plus 1. And so all I did there was long division. I'll do that down below. But the takeaway here is that you can cancel the x minus 1 over the x minus 1, and you get that the limit is 3 again. So now let me do the long division. To show you that the claim I made earlier is true. And that's that x cubed minus 1 is equal to x minus 1 times x squared plus x plus 1. So first I multiply by x squared, I get x cubed minus x squared. Then I reverse the signs. I get positive x squared plus 0x. So then I'm going to want to multiply by x. Now you get x squared minus x. Flip the signs again. To cancel, and you get the x minus 1, so then you multiply by 1 and reverse the signs, you get 0, so the remainder is 0. So that whole long division is just showing me that x squared plus x plus 1 times x minus 1 is equal to x cubed minus 1. Okay, and that's how I was able to say that the left hand limit is equal to that right hand limit there.